And now let's look into a bit older data. I'm going to demo you I'm going to show you the um, ash weight change. So I'm going to, ash top itself is fairly simple script, right? Just kill this, okay? Um, I'm gonna log into. I'm actually here. I'm logged into a different database. It's not my laptop. It's a different database where I recently generated a bunch of data. So let's select start from with our ash info. So it's 1:15. Yeah, it hasn't actually managed to even keep. Is it 12th of September, 12:24? Actually, you see, this is an example. So this is a different system. I guess the amount of activity there and whatever memory Oracle allocated, you see, it's 1:15, but the oldest sample is from 12:24, so it actually has less than 1 hour of history in this $V view. So that's why, again, it's, let's just use the dash top, which is a bit less granular, but it's still good enough. So I'll go to the weight change script in a second, and I'll just explain why. So let's see what happened earlier today. Again, I mean, this syntax is actually easy, and I have this in my command line history usually, so it's very easy to retrieve it and so on. I just want to see what this database did over 6 hours. And perhaps let's look into, let's drill, you see we've seen some buffer busy waits today earlier. And you see, apparently the first buffer busy wait like this was at 9:08 and the last one was at 9:40, right? So let's perhaps take from 9 to 10, right? Let's drill down into what happened from 9 to 10, okay, in this system, okay? So, most of the time was spent on CPU and just regular single block reads. So that's, I don't really have to focus on whatever else is going on here, but I'm just curious about this, right? So let's say I'm wondering. I mean, it's okay to do I/O. That's what databases do, and it's okay to use CPU. That's what databases do, right? But let's say I'm wondering, why do we have this, this concurrency wait events, and there's also like some configuration stuff and so on. So that's interesting. So let's say, why do we have this concurrency wait events? Some sort of contention showing up. Okay. Wait class equals concurrency. And now, okay, let's just do a breakdown like this. Oops. So apparently most of this concurrency waits have been, 300 seconds. They've been against a file header block. So it's actually not the file, it's not actually the block number 1, it's the block number 2 in a file. It's the space header where where the LMT tablespace files keep their, metadata, right? And so there is some sessions, for some reason, have waited for this wait event. So I don't know, let's look into username, SQL op name. What have they tried to do? So user SSH is one of my benchmark users. This guy apparently has tried to run an insert statement. Both of them have been inserts, which have ended up waiting for this. So whenever you wait for locks, or somebody's blocking you, or you wait for contention, then it usually means, it must mean that somebody else has taken a lock or a resource of which you want to take as well. But because somebody else holds it or keeps it busy, you will like sort of back down and you cannot use it. And for these scenarios, let me just get rid of this. For these scenarios, you can actually see blocking session status blocking session. You see, whenever you are waiting for a lock or some sort of a contention event, then you know it must be because somebody else is holding a lock on this object already in an incompatible mode, what you want to get as well. And apparently you see, and in all cases Oracle has figured out who was the blocker. So the blocking session status is valid, so that we know who was the blocker, and this is the session ID. For completeness, I should actually have the blocking instance ID here. Blocking I think it's inst ID or something like that. Nope. Inst. I think it's blocking instance. Nope. Oh no, sorry, I have a typo here. I'm silly. And serial number as well. So now I don't remember which blocking instance, blocking session serial number. Okay, serial number went through. Now it doesn't like the instance. I think it's blocking inst ID. Okay, right. So Oracle doesn't always figure this out, but sometimes or often, usually it does figure it out, and it depends on the wait event as well. And you see, in all cases, the blocker has come from the same instance, and this is the blocking session ID and serial. And I know the time range of interest. So because now what I can do is I could just see, okay, what was that session itself doing during this time, right? What was this session? I should ideally take the first scene and last scene, but I'm too lazy. So what was this session doing during this time? Because that's the blocker. Now I can go and see what the blocker itself was doing. So I'll do this. I don't know who was the blocker. What is the SQL op name, and what is the SQL ID? And I want to see everything what this blocker was doing. I don't only want to see if it waited for concurrency. I want to see everything what this blocker was doing. But actually what I need to do here is where I'll just say session ID equals 371 and session serial number equals this. Okay, you see, I just listed what did this blocker itself do in the last hour, right? Ideally, I should probably zoom in to specific weights like this second perhaps, and and see what the blocker was doing, and I can actually see what perhaps what wait event the blocker was waiting for. Okay, so as you see, this starts to get complicated, and that's exactly why I actually have a script for this kind of stuff. So it's called ash wait change. So remember where we started from. We sort of started from, we started from here. We looked into like a full hour of data or of history, and we saw that, hey, why are we having this concurrency buffer busy waits? And we got curious that why do we have this? Okay, so I can run. So I have the new script, what I mentioned, or what I promised to show. Instead of ash stop or dash stop, I'm just gonna use ash wait change. Ash wait change now uses the blocking session info to walk through the chain of blockers for me. So I don't have to do this manually. You see, it got complicated. So basically, and I can also say that, okay, I can specify a starting point. Let's just say, hey, let's see event 2. Let's show only the wait events, and the starting point would be this: that wait class equals concurrency. Show me everybody who waited for a concurrency wait class event, and show me like a full blocking session tree or blocking session chain, that why did we have this? Because again, you know, the moment when you wait for a lock or concurrency or something like that, you want to know who blocked you and what the blocker itself was doing. You know, this is the point of this script, right? And what you know, the most basic mode, I'm only reporting the wait event. This says that, hey, in the last, or in this hour, like 49% of time, somebody waited for buffer busy waits on this file space header block because somebody else blocked them. And this blocker itself was waiting for control file parallel write. And here again, like 18% of time, somebody was blocked, from using this file header block because somebody else had already, locked this block or pinned the block, and this somebody else itself was waiting for this wait event. So you could add like program as well. So in this case, I see that actually, let me add the username here. Well, let's just do username. In this case, it's all the same, benchmark user. So, so basically, this shows. I mean, we already know on which block the contention is against, right? But it also gives us, this sort of indicates, when you look into the percentages, I don't have to worry about that much. I don't have to worry about, these signatures. But in this case, it looks like majority of the time is spent on these signatures, right? And apparently, let's say data file init write is that somebody was extending a data file, because we were actually loading a lot of data, so we had some concurrency. Somebody was extending a data file while we ran out of space, our insert, and we also wanted to extend the data file, but we couldn't because somebody else was already doing it, right? And the control file parallel write is pretty much related to this kind of file operations as well. So let me just do 1 = 1. Let me show you everything, like a full picture here. So let's see what else. Do we see anything else interesting? Tables. Somebody wanted to get the table space enqueue, and they couldn't because somebody else already held the enqueue, and this somebody else was extending a data file, right? Here is an example that somebody was waiting for log file switch checkpoint incomplete, right? And it was blocked by, when you wait for log file switch, whom do you really wait for? You really wait for log writer, right? But when Ash sampled that, log writer itself happened to be idle. So that's because Ash doesn't have a read consistency, and then things move really fast. So log writer probably was busy doing work, but at this particular specific moment, it happened to be idle when Ash got to sampling it. Okay, and somebody has waited for CR and Q, block reuse, block range reuse, and essentially you're waiting for checkpoint. Okay. Let's see if I have anything else interesting. So it's all buffer busy waits. Somebody's waited for flashback buffer free, and that's actually a wait for the flashback. What is it? Recovery area writer or whatever it was called. I've already forgotten. Okay, so I have and basically you don't have to stop here. You can just say you can just say program here, that you see the wait event and you see the program, right? And sometimes the program is a background process, right? So here's a background process and so on. You can also say SQL op name, right? So most of my activities here were because of insert. You see, here's buffer busy wait scenario. We wanted to do an insert, and we ended up waiting for this, for some other session who was also trying to insert, right? And ultimately, we were waiting for DB writer. So that's actually a fairly weird scenario. So this probably has to do with normally regular user processes don't wait for DB writer directly, but when you extend data files or add data files and so on, then DB writer might get on the critical path or get on your way. So if I do a program, yep. So I'll stop here. So I think to not spend too much time blabbing here, I'll show you a couple of so here is a blog entry. I'll put it into the chat as well. It explains this in more detail. So this actually is a similar scenario. We had such a buffer busy wait scenario. AshStop only showed buffer busy waits, but it doesn't really show you whom you are waiting for. It doesn't go deeper into these wait events. But my script will walk through this wait change. And this happened to be on Exadata actually. So these wait events at the the ultimate blocker is this, and these waits sort of kind of illustrated that this is related to data file extension. When many sessions want to load data at very, very fast, and there is only a single big file in the table space, then you have such contention, right? And you either need more files or bigger extend sizes, or pre-extend the table spaces, which Oracle tries to do under the hood as well nowadays. But that reduces this contention. Okay. So and this is really good for giving you an overview of complex topologies of weights, right? And it's almost like running hang analyze, but based on Ash data. It sort of analyzes who waits for who, right? And you can filter it how we want to, and you can just choose whatever columns you want in here. Okay. So let's see what else. I think I'll, because I'm over time, I'm going to skip the event histogram, so you can actually query wait event sort of durations from Ash as well, or estimate them. So, but I won't do that. Maybe a different session. Okay, so what else? So let me go through some questions and let's see then. Joseph, yes, I mentioned that normally DB writer does not get on the direct path or the critical path of user sessions, right? But Joseph mentioned that, hey, but if DB writer, if your IO subsystem is so slow and DB writer cannot write dirty buffers out fast enough, then you might see that. And yes, indeed, you would see actually there's a wait event called free buffer waits. When you see that, it means, it doesn't necessarily mean that your buffer cache is too small, but it's rather that your DB writer cannot write data out fast enough to keep some buffers free and reusable. It cannot write dirty buffers out fast enough. So either you make less blocks dirty, do less DML, buy faster storage systems so the DB writer can write out faster, or sometimes increasing buffer cache helps you sort of delay this problem, right? But yes, and this is the wait event that will show up, and possibly, I haven't checked, DB writer will be shown as your blocker then, and that will show up here. Okay. Okay, so yes, all the scripts are downloadable. That question has come up a few times. Somebody asked if the highlights are part of the script. It's just how my terminal works. So I'm using a terminal called Terminator, which is not the same Terminator what you have on Linux. It's a different one. And with Command F, I can just use, like a regular expression to highlight whatever I want. If I type buffer in here, it takes everything start with buffer. Or if I remove this regular expression, then it's just buffer. Okay. Wait chain event name, where do you get that from? I'm not sure what the question means, but when you use event2, then it prints you out whatever wait events it sees on the path, and it's now the starting point. This is where you can specify whatever you want. Maybe you don't care about anybody else. You just say our username is something like this, right? Okay. So SSH users experienced these waits, right? And now they were blocked by a lot of other sessions, right? But I've written the script so that this filter only applies as the starting point of walking through the waits. You might be blocked by sys or something, right? So then, despite this filter, I include sys and everybody else down here, but the starting point is whatever you specified. Okay. Is there any option to use these scripts with StatSpec and without AWR and these licenses and so on? Then no. So because this is Ash, right? So active session history is part of Oracle's. So if you only have StatSpec, you don't even have this kind of sampled info, unfortunately, right? But I will. Somebody already mentioned there is a. There are some tools written by community which sample WDL or session every now and then, every second, and that looks like Ash as well. And a lot of these techniques are usable, or some of these techniques are usable there as well. But I don't have scripts for that, unfortunately. So. So does this work in PuTTY as well? And it doesn't matter which terminal it is. It's just terminal, but it's pretty wide, right? So you might want to uncomment some of the columns if it's too wide, or you can run SQL developer. You see, I'm not going to run it here, but you see, I've used an old script, and in SQL developer, you can run it as well. It doesn't format it exactly the same way, but at least you can scroll left and right. Right. Okay. What else? Because Sailai asked if you can show blockers based on transaction, weights, TX and Q weights. Blocker, yeah. So let me just. Maybe I have, because I just ran a benchmark, so so this is a different database now. No, I don't have any TX weights in here. Let's see if I happen to have more history in memory. Nope. But what I can do here is I should have some. If I go to the dash one, I should have some TX weight. Yep. You see, that's an interesting one. So this is you can use. We only see a few entries. Let's see if I have longer history. So 30. Okay, so that's better. So I just take 30 days of history. Let's see if I have 90, and I'll just say event to like I'll just okay. I have to put this into double quotes again because this is the filter parameter. Let's say I want to only know people who waited for this wait event and why. Okay, so this is, you see, well, it's a nice example actually. It's a good question. So in this case, there was some session. Let's add SQL op name. You see, there is some session who tried to run an update, but they ended up waiting for this TXNQ contention. And the blocker, when we walked through the blocking info, the blocker itself was idle. At that time, Ash didn't have any records. We know what's the blocking instance, we know the blocking session, and we know the blocking serial number, session serial number, we know that. But when we looked into Ash to find it, we didn't see a sample. Because Ash doesn't sample idle sessions. So when you update a bunch of records and don't commit and go and drink coffee outside, your session is idle. It still blocks the other guy, but it's idle. It doesn't show up in Ash, right? So that's why I show this. When I only know the blocking session ID, but there is no corresponding session. So this is an example of the session. This user updating a bunch of records and then going away without committing. Okay. So that's a good example. So, and then you would basically query. See, first seen and last seen. We know the time range when we saw these waits. I could actually go and find that whether between this time range or around that, but whether between this time range, what was this session doing? So I could just say, I don't know, ashtop username program. I know the time range, and I know the session ID and serial number. So I want session ID equals this, and serial session equals this. Okay, and let's take the time range times temp. It again looks like a lot to type, but the structure is really easy, and you can just save this example somewhere on your disk as well. And okay, so what I did here is ashtop obviously doesn't go into that history. You see, this is like from a week ago, right? So I had to use dashtop here, right? And but what I just did here is that because we knew who the blocker session ID was, even though it was idle, then I queried, okay, what else did this session do? That particular seed and serial number during this time range. And that tells me like, hey, it's a user system with this program. I could kind of get, I don't know, module or machine. Like it came from this workstation. So I could actually see who was the blocker back then, who updated records and then left without committing. Okay. So what else do we have here? Here we have a interesting. I have to improve my script so it doesn't actually. You see, here is an example. We tried to insert. But we tried to get this lock while inserting, but we couldn't get this lock because we were blocked by another session. And this other session itself, who was holding this lock, this other session was itself waiting for this wait event because it was trying to insert, and probably, it looks like, this guy was waiting for somebody else who then was doing a data file extension. So, again, back to this original data file extension problem. We could say, I'll just add some program 2, and I'll just add username. So I can add a lot of stuff, right? So now it's like SQL operation name, program username, right? And here, see, we waited for TX contention, and who blocked us because, you know, this wait event, who caused this wait event, right? Or who blocked us. This guy was waiting for this wait event, and in turn, you know, it was trying to do an insert or a regular application, and that user, tpcds. And in turn, this guy was waiting for a background process, space management, slave, or space management coordinator or whatever. So that's the guy who extends data files, right? And can do it asynchronously, but in my case, I was inserting too fast, so I ended up blocked and waiting for it. So you see, I was gonna finish, but we have to have some fun as well. So I'm gonna do one more thing. See, basically what I'm getting at here is, you see there is a TX and Q contention, but when you look deeper under the hood, in this case, in many cases, we were actually indirectly waiting for tablespace extension. And the top level symptom was NQ contention. But when you dig deeper, when you unveil the layers and deeper and deeper layers, you'll actually see that under the hood, the ultimate blocker was tablespace extension. And when you have a slow disk I/O, then that may get worse. You know, if you have a lot of inserts and data loads like that. But let's have some fun. Let's finish with some fun as well. So I'm gonna rerun my benchmark. Okay. So this will do a lot of transactions. Let's look into last minute, right? Let's look into last 5 minutes. Okay. There was a question, what is the event 2? I mean, normally I would use event. That's just a wait event, right? That's the wait event column in Ash. But you see, it doesn't show on CPU. It shows null here. So, you know, it's and it doesn't show me the buffer busy wait block type and so on. So event 2 is like event, but I have, you know, if you look into the script, you'll search for it, you'll see what's in there. It's an extended, better version of that column. Okay. So now my benchmark is running. Let's see how many users we have. Let's add more users, 10 users. We're doing lots of transactions. Okay. Let's do, so I cannot have, as I've documented in the blog, I cannot have commas here because of the syntax what's used. Well, different statement types, but let's see what happens. Let's have some fun. Don't do it in production, please. I'm gonna do kill minus stop log writer. I'm not gonna actually kill the log writer, I'm gonna suspend it. Okay, so you see, right now we are consuming IOs, you know, CPU, doing transactions, 70 transactions per second. Okay, now I suspended log writer. You see, all the resource usage stopped, right? Or a lot of it, and you know, basically we are hung probably, right? So I cannot even well, I'm logged in as sys, so that this query should run, but let me because sometimes when you have a log writer problem or archiver stuck, even a regular DBA cannot log in because auditing wants to insert and commit something under the hood, right? But sys should usually be able to log in, right? But perhaps my query is, I don't know what, maybe Oracle 18 has some more complexity. But I will now resume log writer, right? Continue. Now this query finished, okay? And you see my benchmark runs again. Oops. Let's see if we can see anything different from here. Yeah, I guess my workload is too simple. So what I wanted to show you is actually just an extension of this. You see how sometimes somebody locks a record, and let's say this user locks a record, and then they want to commit, but they cannot finish the commit because log writer is stuck or archiver stuck or data guard issues or something like that. And then everybody suddenly starts waiting for TX and Q because they want to get the lock. But the ultimate blocker is actually, ultimate holder of the lock is actually waiting for something else like log file sync. That's what I wanted to demo, but my workload was just too simple. So, but hopefully this shows you that there is more to this story. You cannot only run an ash top or statspack or some sort of a top wait event report. I mean, when it's just a simple IO wait event, then it's easy. I mean, you just have to do less IO, tune your SQL, better indexes, or more buffer cache or whatnot, right? So to do less IO, that's how you optimize that. But when you see contention wait events, starting from simpler stuff like TX all the way to buffer busy waits and even latch contention, then that's then you have to walk. You have to know who is the blocker and what is the blocker itself doing, right? Because maybe 90% of these big wait events in the top here are caused by just one specific problem, right? Okay, I think I'll stop now. So I'm like 52 minutes over time. So, and I hope it was useful. I'll upload the videos as well. I'll upload these slides as well. So I already demoed ASQLman as well. You can log in. You can look into your OLTP-like queries and easily drill down and see where on which plan line they spend time as well. So that it's all there. But this requires Ash, right? Other tools don't have this info. Okay, so the scripts will be here. The video will be here. My scripts will be here. Just click on the downloads. I mean, I already uploaded the scripts a couple of hours ago, so they are there. I think somebody had an issue running it. Please send me an email when you have some sort of a data type mismatch error. Let's take this offline. And yeah, I mean, if you're interested in training, I mean, with more structure and with demos more likely working, right? Then look at this. I have like a SQL tuning class and then my advanced Oracle troubleshooting class. And since I want to geek out and go really technical for about 6 months, then I'm also putting together a Linux class as well, where it doesn't only have to be Oracle. It's either other databases or some Java app or some web server. How do you troubleshoot these kind of things? When these are slow or hung and so on. So check this out as well.